Hello class. I'm going to be performing experiment 9 today with titrating an acid with a base. So first off, I'm going to show you how to set up a titration. And here we have the clamp stand, and then we have the O-ring stand connected to the clamp stand to hold the burette in place. We have the burette. We have the stopcock that's connected to the burette to stop the water from coming out and to let the water drain if we needed to. And then we have the titration flask, and this certain flask that we're using is the Erlenmeyer flask. So the goal of this whole titration procedure is to calculate the actual concentration of sodium hydroxide solution that we made. And I'll show you step by step how we do that. So first off, we're gonna have the two solutions that we're gonna be using today are in our titrant, we have the solution, which is sodium hydroxide, and then in our analyte, we have our KHP, which is the potassium hydrogen phthalate. We also have our inside, before we even start to drain our titrant, we have our color indicator, which is in abbreviation is PHPH, which stands for enol-phthalate. That's our color indicator. We use that specific color indicator because it'll change it to a color at a pH that's pretty almost exact to the equivalence point that we're looking for. We use that color indicator because our titrant is a clear solution and our analyte is a clear solution. So it'll turn it a different color, and then that's how we'll know that the acid and base, they neutralize each other. Okay, so when we have the analyte in here already with the color indicator, we're going to try to look for the stoichiometric equivalence point, and that's what we're going to see that has been reached. The stoichiometric equivalence point is that means like once the base and the acid, they neutralize each other, meaning there's an equal number of moles of the titrant to the analyte, which is once again the sodium hydroxide to the KHP. Okay, so now when we add the solution into, we start to add the titrate into the analyte. We do it kind of one drop at a time because it has to be, it turns a certain color, and it'll turn a darker color if we do it wrong. So you kind of want to just do one drop at a time and be patient with it. When you add one drop, you kind of want to use a swirl to swirl inside the flask, or even swirl it on your own a little bit, and just be patient and gentle with it, and it'll slowly start to turn like a faint pink. So when we do that, we turn the stopcock, and we have the titrant running one drop at a time, and then you'll see the chemical reaction happening here with the hydrogens and the hydroxides. The KHP, which is in the analyte, that's what's known as the primary standard, and we know that that's a primary standard because that's the solution that we know the identity of it, the concentration, and the purity of it. So that's going to be our primary solution. The primary standard. The secondary standard is the KHP. Sorry, not the KHP. The PHPH, because that's our standard. That's our standard. That's what we're standardizing against the KHP, which is the primary one. So this is our final solution. This is what it'll look like. It'll look like a faint pink down here, and we'll have some of the titrant already out because we added about a couple drops to it, and we patiently waited until it turned faint pink, and that was our goal. We wanted them to neutralize each other, and that is it. The volume and the concentration, it didn't overshoot, and that's what we like to get. Thank you.